To determine Neptune's diameter, we just need to take a snapshot of it and analyze it. So between the red line on the top and the red line on the bottom we have 8 seconds. And so when I then measure Neptune's diameter, it comes out to 2.2 seconds. So then I need to plug those numbers into a calculator, following the equation that's given in the book, determining the diameter of an object, which is 2 pi. That's just a conversion with dividing by the 360, that's just a conversion. 2 pi times the distance from us to Jupiter. So 2 pi times the distance, which is 30 AU. We also have to see where in the part of our orbit we are, and I checked that we're virtually 30 AU away. That times the astronomical unit, which is around 150 million kilometers. So 2, 3, 1, 2, 3. There's the 150 million kilometers times the 2.2 seconds. That will have to be converted to degrees, which means I divide that by 3,600. I did that on the side. I come up with 0.00061. That's the 2.2 divided by 3,600. And then, according to the formula, I also divide by 360 degrees. And I guess I made a mistake. Let's see what happened. Oh, one too many of these. One moment. Okay, hit enter again. Around at 48,000 kilometers, and when you look in the book, Neptune has a diameter of 49,000 kilometers, so I'm pretty much right on given the slight inaccuracies that I had. Determining the density of Neptune is just calculating and using information that we already have, which is the mass, and we determine a mass of 1.027, and I need to move the calculator a little down so I can actually reach the button that I need. 26 kilograms. I'm going to convert that to grams, so times 1,000. There we go. And the volume of Neptune, which is easily derived from the radius via volume equals 4/3 pi r cubed. So I'm going to do 4/3 times pi. Again, I have to move it slightly so I can reach that pi. Pi times r cubed. Well, that's not 48,000, that was the diameter, it's 24,000 kilometers, and if I use the more exact value of 49,200 kilometers for the diameter, then I can use the more correct radius of 24,000 kilometers for its radius, the published one, and I need to have that in meters first and then even centimeters, so yet another couple of zeros, and that needs to be cubed. And I come out with these two numbers, so it's going to be 1.027 to the 29th. Again, I need to shift the calculator so I can actually reach that. 29th divide by the previous answer that I have here, and I come up with 1.65 grams per cubic centimeters for the density, and what you have listed in the book is 1.64 grams per cubic centimeters, so again, that's right on. So to determine what the atmosphere of Neptune is made up of, we take a spectrum of Neptune, and this is what we come up with. And when we look at it in colors, it looks like this. So there are large absorption bands in the red, and we compare that to the laboratory, which then says then we see Neptune visually by the light that is reflected from its clouds and scattered by its upper atmosphere. There is no solid surface to reflect light. The dark bands in the red portion of the spectrum are due to absorption by methane CH4 molecules in the outer atmosphere of Neptune. And for other elements and molecules, we would go into more detail and figure out why they look that way. And there's one more sentence here which says, with so much red removed by the methane from the reflected radiation, the planet appears blue-green in color.